Hello everyone. Welcome to the second video of our series for the University of North Texas Physics Department, talking about physics demonstrations with the help of our physics demo room. Now today we're going to be talking about a very interesting concept that some of you might be concerned about is going, what is a volume and how do I compare it with a liquid object and a solid object? Now, most of you have probably heard of volume and always refer to, let's say, a liter of cola, a 2-liter bottle of pop, a gallon of milk, or some of you might think, oh, the volume of a box, or where it's a length times its width times its height. Or you might think of the volume of a sphere, which is 4/3 pi r cubed. Now, these different shapes just means how much stuff or how much items can you fit in order to make that shape, or what it needs to be in order to compose that shape. And so today we're talking about a little bit different idea, which is going, how do we get this concept of, I have a solid box right here. I know its volume. I can calculate its length, its width, and its height. I can calculate that. I can fill that up. But another concept that we have is also a liquid, and a liquid can make up that volume, but a liquid, since it is a liquid and not a solid, will mold to the shape it actually contains it. So we actually have a lovely conversion between a liquid measurement of volume and a solid measurement of volume. And the liquid measurement of volume that we have to a solid, a lot of you might have been introduced in biology and chemistry. And that is a milliliter is equal to 1 cubic centimeter. I didn't say a centimeter, I said a cubic centimeter, which means it's a centimeter times a centimeter times a centimeter. It's a centimeter cubed to give you a volume. Now, to help illustrate how we can kind of convert these two things, what I have in front of me right here, this is a cubic centimeter. It has an edge, a width, and a height of 1 centimeter each. So this is 1 cubic centimeter. So what I can do is I can say, well, if I want to make 1 liter out of a cubic centimeter, that means I need to have 1,000 of these little guys. Now, if I just randomly throw them in there, because they're solids, they won't get the same volume as a liquid, because a liquid will move around with the other particles in there and adhere to the shape. But with a solid object, we can get the same volume. We just have to actually be more organized. So now, if I need 1,000 of these little cubes, maybe I want to stack them in different objects or different rows. So I might say, well, let's make a nice pen looking object. As you can see here, these are all individual lines. Hopefully you can see right there. And this is just 10 1 cubic centimeters put together. So right here, this is 10 cubic centimeters long by 1 cubic centimeter wide by 1 cubic centimeter tall. So this is a 10 cubic volume piece. So now if I took one of these and I had 10 of them across, I would have 100, which is this little piece. As you can kind of see here, you see all the little grid lines, and you can count across. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces across, 10 pieces down. It's a grid similar to a matrix. I know some of you might be scared of that word, haven't learned it yet, or some of you are thinking about the movies from back in the day. Don't worry about it. We're going to just talk about this little piece. So right here, this is 10 by 10. 10 by 10 gives us 100. So right by here, this is 100 cubic centimeters because it's 10 across, 10 down, but 1 high. So it's 100 cubic centimeters. So if I have 100 times 10 will give me 1,000. Well, here is a box that if you look closely has 100 all the way up to 1,000. So if I was to put all of these pieces in there, I should get 1 liter of volume, but using a solid object instead of a liquid object like most of us might usually think of when it comes to a volume. Oh, beautifully placed inside there. But this is also a cubic liter, or this is a liter of cubic centimeters. Granted, it does have a hollow hole in it, but the overall outside shape is the exact same. So what I can do to verify that is that I can make the outer exterior. This should give me the exact same idea. It might not be a solid interior, but it fills the same volume. So this just gives you a little idea of how can we think about a liquid abstract with volume, and how do we place it to a solid concept. Well, that is all I have for this lesson and for this demonstration. Thank you all for your time and your patience, and have a wonderful day.